All right, so let's get started. So I'm going to describe the tasks in a little bit more
Hmm.
detail. So your first task will be converting an implementation of the try data structure
Hmm.
from Java to Python, and you're going to do this one with the AI support. And then your second task will be converting an implementation of the priority queue data structure from Java to Python, and you'll do that one without the AI support.
Hmm.
We'll take a break between the two tasks because this session, it will take the 2 hours.
Hmm.
So let me tell you a little bit more about the code translation task. The task is to produce a complete and working Python translation within the
Hmm.
30 minutes. By complete, I mean that all of the functionality, all of the documentation from the Java code should be translated. And
Hmm.
by working, I mean that the Python code, it should be kind of tested for correctness. But
Hmm.
as I mentioned, as you know, there's more work to do to accomplish an absolutely perfect translation than what you can do within the 30 minutes. So really, I'm just asking you to like do as much as you can in the time that you have. Um, but there may be trade-offs in how you spend your
Hmm.
time, such as whether you choose to translate all of the functionality first or translate a portion of it and then test it to make sure it works. How you navigate this trade-off is entirely up to you. There's a couple other things I should mention about the task. First is you will use an online version of the VS Code editor in the study. If you've never used it before, it has a couple minor differences from the desktop app. But in general, all the things like the menu commands and the keystrokes, they're available and they should just work. But if you do have some difficulties, please let me
Okay.
know.
Hmm.
We will not be able to answer any technical questions you have about the code or what it's supposed to do.
Hmm.
But I can tell you that the Java implementation is correct. When you make the translation, please do try to preserve things like the naming of classes or the naming of
Hmm.
methods. But we're less concerned with how you name variables.
Okay. Okay.
And also you can use whatever resources you feel would be helpful. So if you need to search the web or Stack Overflow, or if you need to run any of the code, we have installed Java and Python runtimes in the editor, so you should be able to do those things.
Hmm.
And then I'll give you kind of a 5 minute heads up when the 30 minutes is almost finished, so you know to wrap up your work. And then the last thing that we ask is, as you work on the tasks, we would like you to kind of think out loud and
Hmm.
just vocalize what you're doing, what you're thinking about, because that's really going to help us understand like how you're approaching the task and what you're thinking about and what you're doing and why you're making certain decisions that you're making. And
Hmm.
so, if you're quiet for a little bit too long, we might nudge you and just, ask you what's going on in there.
Yeah. Yeah. Right.
So,
Cool.
all right. So, any questions before we get started, or?
Um, so yeah, it all makes sense so far. Um, I got that all the technical stuff related to code is up to me, but I'm going to just ping you if something goes weird with the online VS Code or
Hmm.
yeah. Okay.
Okay, perfect. All right, so let's start with the first task. So this task, as I mentioned, you're going to translate the try data structure from Java to
Hmm.
Python with the help of an AI code translation system. So this system is able to automatically translate code from Java to Python, but it's not a perfect system. So the translated code, it may contain errors in it. And
Hmm.
we've used this system ahead of time to create 5 separate Python translations for you, which you're going to see when you open up the editor. But how you use these translations to help you complete the task is entirely up to you.
Okay.
So let me share the URL here for the online editor. So if you can go to that, and also if you could share your screen now.
Okay. Let's just copy paste. And so I'm going to turn a little bit and use the other monitor.
Sure. Yeah, absolutely.
Um, that's so you're going to see the not the WebEx screen, but the work screen kind of. So opening up the environment, magically loading.
Okay, I can see your screen.
Okay, so this looks like VS Code. Okay,
Okay.
so I think I start just
Yeah,
getting
so
an
before you
overview of
get
the Java
started,
code.
let me just ask you one thing is can you zoom in maybe one more time just so we can see. The code is a little bit small for us.
Yeah.
Um,
Um,
yeah, that's good. Is that good for you?
that works for me. Okay.
Okay. All
So
right. So one final thing is you're going to see this one file try.py. That's the one for you to put your solution in, and then
mhm.
the 5 translations that I mentioned, those are
AIs.
try AI 1 through 5.
Okay.
Okay. So I'm going to push the start button on the timer, and you
Mhm.
can get started now.
All right, then I'm going to first just get an overview of the try class. Okay, there's a node, class node, and we have a root. Then, okay, inserting, binding, basically the interface. Okay, I'm not going to try to fully understand all of the code. I'm going to have a look at what the translations actually did and what we have to work here. Okay, let's turn this into 2 separate classes. The first one, try node, try. Very much duplicating the interfaces. Okay, so second one, just okay. Haha. Okay, so from a first look, I cannot spot differences, which is interesting. Okay, so what my general high-level approach is going to be basically based on testing, trying to make most of the translated code by identifying which part of that works. A combination of looking at it, does it make sense to me? And then trying to come up with tests to verify functionality step by step. So the try node looks very similar. At least I cannot spot the difference. So let's just take that and get started. Okay, then I just going to start with skeleton more or less of the class. There was the okay, so can we please, I just want to get rid of the indentation here. Okay. Okay, that actually worked. So now I need to get a bit of a look at Python unit tests, because I know there is a unit test library. I just have not really looked closely, and unit tests would be the thing to start. Actually not. Okay. Because we only have a couple of minutes. So, and let's do this the Harakiri way and then just run stuff as code. Basically building an impromptu exercise code for the try, and just make make sure that this is actually doing something. Run. This is a Python file. Okay. Okay, so there's stuff happening. Okay, so then let's go through the interface one by one. So first we need to be able to insert nodes. Okay, and our items are strings. And so yeah, we should be able to insert these two, and we should actually find them. So this will fail, and just trying to look at different implementations kind of side by side, and just really trying to be lazy, and if the AI did a good job, then I don't need to do that work. Okay, this is so they are differing a bit in terminology, but otherwise look the same. Okay, so this insert should fit. No, I'm mistaking the browser tabs for tabs here. Yeah, so let's give this a shot.
So what are you thinking about right now?
Yeah, okay, just trying to got confused here. Okay, so there's basically a bug in the generated code. It forgot a self dot. Let's try to. So I'm basically trying to iterate a bit over running the code, and try to be lazy. And we're did I mix different? Did I just mix different? Different of the translator. I think I started out with the AI-1. Okay, so what happened? Current.children.setDefault. So the try node should have children. Current dot children. So this did this try to, okay, so what did that try to do? Okay, so what I'm doing is trying to figure out why this auto-translated code that looked innocent enough would not work. So, okay, so currently we're starting at the root, current to children. Set default, but this children is not actually okay, so this set default, is that actually a thing? Because this looks strange.
So just to clarify, you're trying to figure out what this set default thing is about?
Yeah.
Okay.
Because it's like in the back of my head, this is telling me something, but yeah, okay, exactly. So yeah. Okay, so this is actually fine. This is okay. Trying to getting lost in what we're actually trying to do here. Okay, so just for background, okay, hmm. So okay, let's actually just go here and debug this into the step by step, because then right here what's going on. Okay, so we're going through the character step by step. And then trying to this is okay, so current children. Okay.
So I guess
Okay.
could you say a
Yeah.
little bit about maybe what's confusing you or what you're
Yeah.
expecting to see here that you're
Um,
not seeing?
so yeah, so now I kind of got hung up by, okay, the AI did code for me and I need to catch up in understanding what it's doing and trying to debug that. And what I'm seeing from this is, okay, the semantics of how we add nodes to the try looks like in the first step that worked out fine. We kind of added the children, probably not the right thing. Then we try to go to the next level. But yeah, now what we added this C for C in current.children. But that's not a try node, so we probably try to add a try node and that did not work out. So yeah, then we try the next step and that actually falls over. Okay, so assuming that the AI did something a bit more clever. Yeah, that code looks very similar. Okay, so trying to make sense of this generator expression. Okay. Yeah, I'm a bit surprised by parts of Python I haven't looked at closely. Which is a bit interesting in the sense of, okay, someone has generated code. Now I have that generated. Yeah. How does that actually work? Not sure how this should actually be behaving. Okay, so basically list comprehension, but yeah, somehow we're not using this the right way. So let's have a Python. I'm just opening a local Python. Okay, so this is at least making somehow sense. There's just nothing there. But we should actually not. So I'm still trying to wrap my head around what is this code. It's great Python code, super compact, but you need to unwrap it, and right now it does not really make sense for me yet. And effectively, all the auto-translated versions do the same thing. Okay, and this is probably just a massive computation failure, because yeah, okay, this is probably just a foobar translation failure, because in Java this kind of makes sense. Okay, so I try to find a node that's present, and if not, then I'm building a new one, and Python code just does not do that. So actually, by being a human programmer, this should actually look something like this. If I don't find a node, I'm generating a new one. So would that behave more reasonably? No. I need to save this. Come. Okay, got a bit confused. So okay, we did something, and actually getting to find. Again, the self dot is missing, but that, I've actually seen that before. So trying to just run it and trying to make sense of the code. Okay, so no idea about the inner structure of the trie, but at least it's doing something. We can insert and retrieve entries, so that's good. Then I would just speculatively move forward and yeah, just get something like, oh yeah, so talking about inner structure, enumerate is something that should give us an idea. So again, try.
And just so you know, we have about 5 minutes left on this one.
All right, okay, thanks. So okay, and this just looks very unexpectedly broken. Oh, this is actually okay. Okay, this is again looking funny. I kind of got used to not trusting the AI generated code too much. Been a bit more optimistic before. So this is what I'd like to happen. And okay, so this tries to, this is just not making sense. The Java code, however, kind of looked reasonable. And then the AI probably kind of got confused. Okay, yeah, string builder, yeah. So we start with an empty string and the root node and entries. Looks like reasonable. Self.root, of course. Entry node entries. Oops. Okay, so no overloading in Python. So this is actually in Python you would more like call this something like underscore enumerate or underscore underscore enumerate. And okay, I get children has a different name. Fine. Just renamed this. Mm-hmm. Entries should have been entry.
All right, that is time.
Okay,
Uh, and
that
as you
was
can see,
interesting.
takes more time than you had. Yeah.
Yeah.
Good. So let me send you the first questionnaire here.
Okay. Can I just close the VS Code window, or do we need
Yeah,
that?
yeah, you can just
Okay.
close. Yeah, it's everything's saved, so you can just close this one, and then I'm going to send you a
Okay.
different link for the next task. And then if you could just go to this survey
Mm-hmm.
link.
No. Okay, so yeah, just to give you context on why I'm doing this really weird copy paste. I'm using Linux, and WebEx is just always crashing in Firefox, but Firefox is kind of my main browser, so I have a
Oh,
separate
okay.
Chrome.
That's
Makes
fine.
this a bit
So,
awkward.
yeah.
Okay.
So for this one, your participant ID is P1,
Mm-hmm.
and then you were in the AI condition
Mm-hmm.
with try.
Try.
Yeah, and
All
then
right,
just
I agree to
tick
what.
parenthesis box, and then
Yeah.
okay.
Okay. Yeah. Okay.
Oh,
That's that.
that's fine. Yeah.
The
You just have
typical.
to tick the box. You don't actually have to read it.
Yeah.
Okay. And then I guess, the same one about this is if you want to, think out loud about how
Mm-hmm.
you're reading things the way you are, that definitely helps us.
Okay. Yeah, it just gives you additional data on top of the sheer numbers. How mentally demanding was the task? Um, yeah, so I think what kind of adds is this feeling of being watched, but that's part of the experiment, or this kind of um, but apart from that, and yeah, of course, I'm doing engineering, software engineering, because it's mentally demanding. Um, yeah, I'm trying to calibrate this, how much was kind of the added strangeness of being watched, or this experiments versus the actual challenge of the coding. So I think I coming out on this scale somewhere in the definitely upper half, but it was actually not too involved. Well, it was involved, but not kind of super high demanding. How hurried or rushed was the pace? Yeah, kind of relatively high, mostly. Yeah, no, let's make this an 18. Oh, how successful was I in accomplishing what you were asked to do? Oh, yeah, I like this question. Um, looking at the overall thing, I think we covered 20% or so of the interface, and that did not even probably quite work. So let's be generous and say, perfect failure. No, then we are actually in this area. Yeah, so we accomplished something, but not in related to, not significant in the relation to all of that. Yeah, I had to work hard because I was a bit surprised, and it was a bit interesting to get accustomed to this. Okay, you got some code that's kind of already there. Not sure what to make of that, if it's already working, how much can I trust of that? So I think there was actually a lot of getting this tool, getting used to this. Getting used to this. Okay, you have some translated code. Okay, how insecure, stressed, da, da, da. I kind of stressed myself a bit. So not annoyed or anything, but yeah, kind of stressed myself a bit. Yeah. Okay, then our work process. I think I basically worked in this kind of explorative evaluation and testing of the translated code. Going step by step through the interface and its implementation. Building simple tests and working towards getting basic functionality to run. Yeah, with regard to time allocation, spend a little on very simple tests and then to get a reasonable behavior for them. More like going broad on the interface before really on the existing code before really deeply making sure that it does the right thing. To kind of make the most of what's already there. A little. More or less, I think I relied more on a general understanding of what a try implementation would look like. Yeah, somewhat. Well, regarding to what I've been looking at, trying to make sense of that, relying. Understanding of what to try. Nah. Yeah, I think this is truthfully reporting what happened. Okay, the quality of the provided translation. Okay, so making sense of it from a perspective of, is that good code? Not really, but from a sense of, is this a reasonable translation and kind of giving useful code? Yeah, I'd say, yeah, acceptable. And then makes sense to elaborate on that. Mostly an actual, so basically the code not being able to run, an actual software engineer would kind of have some minimum testing. But yeah, general as something that provides some code. It made sense and at least, yeah, gave a head start. For example, you mentioned that one of the quality criteria is this providing documentation and following the naming convention of the Java implementation. And the translation basically gave that for free. And that as a human, that's kind of the boilerplate copy and paste. So the translation was somewhat useful, yes. It definitely had a great deal of errors. Probably in particular some that some checking of Python code might have caught, like this self.root, this type of errors. Helped complete the task? Yeah, I think that actually helped. Helped understand the original Java code. I would say yes, somewhat, or actually, yeah, somewhat, because it provided reasonable insight into what the original Java code would be. Taught me something new about Python? Yes. So did this make it difficult versus easy? It was, I think overall it was made easier than without a translation. And it actually provided, I think it provided speed over just basically doing it myself. It was not that pronounced because kind of I got a bit lost or got confused by how much can I trust this code, or should I really kind of take it apart and start over? So I'm not 100% sure that I interpret this question right. Did you feel that the provided translation made your work in this task of the worst versus of the best quality? I think by providing this structure and code comments and just providing this kind of framework that helped towards quality, but I would not really rely on just the translation for matters of quality. So I think this kind of helped me in a quality a bit. Most useful, yeah, basic structure. Providing basic structure. Transporting interface comments. Yeah. Least useful, well, implementation code that had bugs and yeah, actually hit the intended semantics. Yeah, okay, I think these 5 were enough. It was surprising that the errors I found actually were present in all of the translations. Okay, trying to identify differences. And I chose one as a primary source, and yeah, and referred to the other translations. Identifying potential errors. That's not an English word. So. Okay, maybe totally deep diving. It in particular for debugging where the translated code did not make sense. It could have helped to maybe include the original code there in place. Comments could have helped with debugging.
So when you say the original code, you mean the Java?
The Java code, the original.
Okay. So just like to see them side by side.
Yeah.
Okay. Yeah, and I saw you did that a little bit, right? Because you copied some of the and pasted in as comment.
Yeah.
Okay.
And maybe, and this is just guessing about how this tooling works, maybe there are useful intermediate representations, whatever that would look like, that could kind of, yeah, okay, maybe I'm trying to debug the translator already, but that might kind of help bridge the gap between. So okay, that might actually be useful if I would not be so familiar with Java, and then could have additional semantics on top. Then see, okay, now this is the Python world. Oops, bridge the gap. So, okay, work conditions, normal work conditions. Yeah, I think this would probably be helpful. Another time pressure. Yeah, with a bit more experience in how to handle the tool, probably really should be able to save time. Working alone. Not sure how that dimension would help. Working a code that only I would use, still, I think that would not. For team members, similar. Small team, large team. Okay, so I would like to have this option. Not sure how that would affect it. Or I'm not sure that this particular parameter would.
I say just, use your best judgment for these.
Yeah, yeah. Yeah, I think it's probably experimental or prototype code. Yeah, I think here this would to just splatter out some code. and get working. On production code, yeah, probably helpful, but not just out of the box, not by itself. But okay, we still need tests, right? AI created be appropriate. Okay, definitely. Mission critical. Yeah, I think AI created translations would be appropriated if all other measures are in place. Code correctness is critically important. In mission critical applications, that would be the case. Still very probably appropriate. Runtime performance. Okay, this is hard to judge. I have not seen anything in the example I've looked at that would give me the idea that the translation causes performance problems, but large code, yeah, okay. And yeah, I think it would be really, really appropriate in cases when I am unfamiliar with the language. And yeah, ideally, I should not have to kind of fix when idioms went wrong. So I think this is very important. When the human developer in the game is not super familiar with the original language, because then he might not be able to kind of spot really what's meant. Okay. Next. Other feedback. So I think what would be an interesting follow-up experiment, but this is just where I think, okay. No, what I think is I individually would feel more comfortable using AI translated code in kind of a second experience. When I had the chance kind of to get to know the tool and what to expect. And so just suggesting that could be an interesting follow-up experiment. Like, does it help you the second time when you kind of had time to reflect on that?
Yeah, just At the end of the study, remind me, and I'll tell you what comes next.
Okay. And this kind of this feeling of how bad could it be? Okay. All right.
All right,
So
did
much
it.
about the survey.
Okay, so why don't we take a couple minutes break,
Makes
and then we
sense.
have one more task, and that
Hmm.
one will be the one without the AI so that you can contrast what the experience is like.
Hmm.
So, all right, so I'm gonna take a break. I'll be right back. You probably want to
All
stretch
right.
your legs too.
Then I just stretch my legs a bit.
All
Okay.
right, ready?
Yeah.
Okay, so let's start the second task. So as I mentioned, this task, you're going to translate the priority queue data
Hmm.
structure from Java to Python, and you'll do this one without the AI support.
Hmm.
Let me send you the link. Okay.
So I just
So yeah, so same deal, just drop your solution in the Python file.
yeah.
And so
Is that size big enough, or should I zoom in a bit?
I think that's good for me, as long
All
as it's
right.
comfortable for you. So,
Yeah.
all right, so let's begin now.
Okay. So this time I'm rather split the screen because there's only going to be two variants of the code. So okay, binary heap. Okay, so just I think I actually created a priority queue as a programming assignment for some hiring a couple of years back. I have a quite okay understanding of how that would work. No, not Java. So okay.
So
No,
what are you thinking about right now?
yeah, okay, I just trying to make sense. Okay, priority queue. Okay, in Java, this needs to be parameterized. In Python, we are a bit less strict, so no need to worry about that. So and the priority queue. No. Then we don't need this Java specific. So no, come on, format. Okay. So okay, class priority queue. Okay, this is building the heap with an array list. In Python, we just use a list. I wanted to have the not AI format this for me, but okay. Then insert an item. Okay. Yeah, again, I'm going to follow this roughly. Let's have a rough code that exercise the basic interface. So this should. Of course, we don't have this. And now formatting should work. Okay. So get off. to get a bit of documentation, bit of overview what we're doing here. And then let's go on with the first. First function of the interface, inserting an element. Okay, this is adding the item to the end and doing the bubble up of the priority queue. Okay, yeah, then iterating backwards. Basically, the Python code is going to look similar. Yeah, this is. Let's start out with more or less following the Java world. Python people would probably hate me because it's not super idiomatic. I would actually English was just trying to sift up. Yeah, that's the name. Just to give context. Okay, I'm more or less following the Java code with the simplifications that we don't have an explicit comparator in that sense. And we would remove highest priority items first. So in case parent is smaller than item, we need to flip them. So place the item at place of the parent. Put the parent here and walk up a heap. Otherwise, we are done. So, and as a first sanity check, just going to print this. Yeah, Python has this // So, okay. Yeah, I have not implemented remove, but insert is kind of doing something reasonable. This is by no means a proper test case, but just getting a bit of an idea. Okay, so now we actually have the case where we do some sift up and this kind of does the right thing. Okay, so let's move on and build the remove. Yeah, okay. Yeah, still following Java semantics, or the semantics of the Java implementation. Because in the Python world, that results in reasonable code. Right, and what you do, you take out the first element and then swap with the last. Okay, so that's going to look a bit different in Python. Say last element as heap, like that, slicing. Somehow the slicing and all that in Python is not intuitive to me. This could probably be a bit more efficient, but it will do the job. And okay, yeah, heapify. Basically, we need to restore the property of the heap. And yeah, push the item back down. for just the first idea that I did not totally slaughter the list. Let's try this. Okay, this seems to work. Then we need Heapify. In Java world, that's a private method, so we would call it underscore Heapify. And actually, I forgot documentation describing the interfaces. What are we actually doing here? Insert. Removing. Restore. Okay. So we possibly swap the element with one of its siblings. Actually, I can actually borrow some of that code. Max index. Okay, yeah, we're figuring out which one of them is the largest one. And have heap index. Left index. Now, possibly we have to flip. So flipping these two. items. And then continuing from there. So there's actually a bit of indentation, too much. I forgot. Making similar mistakes as the translation. And okay, so this kind of makes sense. We take the 17 out, then we get the 15, then the 17 out, then we probably flip the one first, restore heap order. So this is kind of already doing good things. Except the moment we take out the last element. The moment we... So where exactly are we getting unhappy? 44. Okay, basically here. We only have one element left. Let me just take that. This would work at least the... Okay. Different semantics. Okay. So we can insert elements, we can remove elements. We can return the size of the test of the heap. Missing self. Peak, just getting the first element, not remove it.
We have about 5 minutes left.
Okay, thanks. So, okay. Then is empty. Okay. And be the same here. Nope. Yeah, and or actually we could try to translate the Java test read if if that exists. So next part of the interface be enumerate. Mhm. Just getting all the elements and basically then restoring it. That's a bit interesting. Sorry, in Python, because we need explicitly to do a deep copy. List. Otherwise, we would operate on the same list and destroy the heap. No. Stack Overflow. Copy.deep copy. Okay. Yeah. Okay, so and then we just collect all the elements while we're not empty.
And time's up. So
All right.
I'll ask you to stop right there.
Mhm.
even though
Okay.
I know it's really unsatisfying because you're so close.
Yeah, it's kind of, yeah, okay. Then
Okay.
I close the window.
Yep. And then let me send you the survey link. Okay.
Okay. Oh, okay. Am I still P1 or do I have a different
Yep.
participant?
Nope, you are still P1, and then this one is the no AI priority queue.
Okay. So mentally demanding. This actually felt less demanding in the sense of more known environment kind of in that sense, but still, yeah, it was demanding. 17 feels right. Hurried or rushed. Still a bit of a rushed job. I think I got close. So yeah, actually a 4. Yeah, 4 feels about right now. Still, that was hard work. Yeah, and actually this was more in my comfort zone. It was more like used work and still, yeah, feeling observed or kind of that being unusual. But kind of small common experience. Okay. Yes. Yeah. So okay, what made that easy? Java code tab, well, basic insert and remove right at the top. Yeah, basically that really this copy pasting helped with speed. Yeah, I do understand how the Java implementation works. And I actually spend more time merging the Java code Yeah, that's a bit of a in comparison, right? That's was more like the only source of truth. Okay. Okay, so we did not have these details, or did we just skip?
No, that was it. Because a lot of the other questions you answered before were specific to the AI.
Okay.
So this was just a couple things about this one task.
Something additional. Yeah, I think maybe that's what I vocalized, but makes sense to put down in writing. This manual translation process just felt just in my comfort zone. Let's call it the trade. Yeah. Okay. Here we go.
All right, so now we have just one more survey for you to fill out, but this one just has some, questions to make explicitly compare the two experiences you had.
So, okay, so comparison translation task with versus without. The actually it made me focus more on that code than on the original code. Okay, and I think what one experience, one observation was that yeah, it was just a different Okay. Yeah, I think that captures that. Oh yeah, the AI. Also, I would really like the AI that actually understands code and can tell me if we have the same understanding. Um, yeah, I think a lot is in this area of debugging. Mm, or mm, mm, oh, I think that's it's more in the understanding, and maybe what would help, what would be a direction is this identifying idioms. Um, or let's say design patterns.
So can you say more about when you say identifying,
Yeah,
you
I
just
think
mean being able to recognize these things, or do you mean like being able to transform your code to make it look
yeah,
more
um,
Pythonic?
right. Yeah, I think this is identifying. I think let me phrase it this way: opportunities to transform my code. Uh, that way around.
Mhm.
Like being the coach, like yeah, being a coach. Um, mm, yeah, yeah, it's like yeah, maybe an AI coach, like an interactive, providing tips, providing hints.
Like helping improve your
Hmm.
abilities as a software engineer, that kind of thing.
Yeah, help me improve. Yeah, and because usually you could do that, yeah, in code review, but that would be a bit of a longer feedback loop. And if I have a tool that really looks at my code, that feels like yeah useful, and where maybe AI like this making sense of patterns would make sense.
Hmm.
Um, yeah, of course I would like to say, oh yeah, give me an AI that helps me debug my code, but I think this is like tell me what's wrong, right? This has been an open problem for decades. So um, understanding. Um, hmm, yeah, I try to that there's something like in this area of understanding, but I don't know how if I'm just trying to have a magic bigger brain that does my work for me, or if there's something where I think, okay, this could actually be a tool. Because yeah, writing software is hard, and if that could be made easier. But I think this identifying patterns or potential patterns, that's something that kind of fits into what I think AI support. That looks like it could be a plausible tool where I would expect, okay, this makes sense.
Yeah.
Okay.
Good.
Then complete this. Yeah, I think this should. Okay, there's more. Yay.
Okay. Just easy question.
Yeah. I am a software engineer. No. Yeah, if it was Java to Python, that would have been.
Well, if you tell me it's COBOL to anything, then I'm going to have a whole lot of other follow-up questions. Assembler. Okay.
Yeah, assembly C.
Well, let me just pause there, right? Because that's also interesting. So, you know, because that's essentially the task that we gave you, right? Like, here's some Java, please give us Python. So, you know, here's some Z assembly, please give us C. How was that? Like, did you feel that was really challenging? Do you feel that like an AI generated, you know, sketch of what a C file might look like would be helpful in that work?
Yeah. I'm not sure that for that specific we would need actual AI support. Because I think I should. So the context was that the scope of code was relatively small. But I think there are probably a lot of use cases in my specific case. The code was small, and a lot of the challenge was understanding the performance properties. But I think that are probably that code where yeah, and I think the semantic difference between large code bases in assembly code and in a language like even C, I think that's very further apart than what you have between Java and Python, where I could get away basically copying some part of the code. And that's probably where like having a tool scaling this doing this in an automated fashion would probably pay off a bit more, or could really pay off. Yeah, if that makes any sense.
Yeah, no, that makes a lot of sense. Thanks. Yeah.
Okay. Yeah, this was fun.
All right. Oh, so just hit. I guess the last question is if you want to do future studies with us, you could always say no to this. That's fine. But if you found this fun, you know, we would.
Yeah, it's a very particular kind of fun, but
yeah,
Cool.
Great, great. Well, let me, you know what? We are exactly at 12 o'clock.
Yeah,
That's amazing.
just in time.
But if you have maybe 2 more minutes,
Mhm,
I could just, tell you a little bit more about what we're doing and the
mhm,
thing that I promised to tell you earlier.
Yeah.
So, as you can see, right, we're looking at there's a certain class of AI algorithms called generative AI algorithms. And
Mhm,
what we're seeing is there's all sorts of models that operate on source code. And
mhm,
so they could do things like translate source code from one language to another, which is what you got to experience in this study.
mhm,
But there are also models that do things like given code, it'll generate documentation, or given a little bit of like natural language, like sort this array, it'll
mhm,
convert that to code. And so we're seeing a lot of models that people are training to do things on code, and what we're trying to understand is like, are these things actually helpful for people or not? And
mhm,
so that's why, in this study, we're looking at, well, if we give you this AI produced code, is it actually helping you be more successful on the task versus if we don't give you the AI and just let you
mhm,
do it on your own, maybe you're more successful there. Um, and so that's this study.
mhm,
We're also looking at what comes next is trying to understand like how these tools are really useful on kind of real world sorts of tasks.
Right.
So some of what we've been doing is we've actually been building an extension for VS Code that incorporates some of these different AI models, so you would actually be able to use it on your own code.
Mhm,
So now that you signed up for the future studies, at some point we're going to announce that this plugin is, the extension is available, and
mhm,
hey, come try it out and give us your feedback and stuff.
mhm,
And there are certain things that we're doing inside the extension to make it sort of easier to work with the model or to help you understand like why the model did what it did.
mhm,
Which you saw a little bit of that here, right? You saw five
Yeah.
translations, and you're like, well, how are these things kind of different from each other? And um,
Mhm,
we're doing some like I'll call it UI tricks to make it easier to see. Like here's the translation, but here's a couple spots where maybe there's some alternate ways that the model thought it should translate, and it makes it more like a selection that you can just say, yeah, I can clearly see this thing is wrong. Like when you were doing the
mhm,
set default thing, right? You might have seen that and then like get a pop-up menu that shows you here's a couple of alternates that the model had considered.
mhm,
Um, Although I think in that case the model translated it the same way for the most part, but just to
Right.
give you some
But
idea what
I
that's
think
doing.
it might even be helpful if I see something, okay, that there's a bit of variability. The model would come up with different things here, so it's not quite clear that
Hmm.
it got it right. Mm,
Yeah, 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 exactly, exactly. You can also get sort of a confidence from the model as to
mhm,
how confident it is that it got the translation right.
mhm,
Um, as it turns out, that doesn't actually correlate with like real mistakes in the code. That was a study that we did, at the end of last year. So even though the model thinks it's,
Yeah.
translated something, it's low confidence. Um, it could be
Mhm,
the case that like it lints just fine, or
mhm,
the model might translate something with high confidence, and it could be the case that, well, there's a bunch of linter errors with this code, you
mhm,
know, go fix them.
mhm, mhm.
So. Yeah, so
Cool.
I hope that gives you kind of a little
Yeah.
bit more background as to what we're doing. We like to do that at the end, right? Because we don't want to spoil how you're going about the
Right.
task and
Yeah,
everything.
well, that makes sense. Cool.
Yeah, so
It
thank
was
you very
interesting.
much. I know this was kind of a massive time commitment. This is usually much longer than, other kinds of studies that we run, but it's for a good cause. So thank you very
Yeah,
much.
I think
Thank you.
it makes sense.
Yeah,
Yeah,
and
and for me,
like,
it's just it's the end of my day. Um, I'm in the Europe type zone, so
mhm.
it's actually not too bad and
All right. Well,
great.
I'm glad you had fun. That was a different kind of fun. And I will send you what did I say? 250 blue points as a token of our appreciation. Thank you very much. Well
Thanks.
earned.
Yes.
All right. Um,
Cool.
anything, Michael, do you want to?
No, just thank you so much. I know this was a lot of effort and uncomfortable because we were watching. So thank you for putting up with us.
Yeah, sure. I think it
Yeah, you
if
helped
it
us a lot. This is really
if
good,
it
really helpful.
provides good data, then it was worth the effort. Great. Then good luck with the study and
Thank you.
Thank
have a
you.
great day.
You too.
You too.
Thank you.
See ya.
Bye.
Bye.